last problem that we did was looking at the log base 2x function, and we looked at it as log base 2 of 2x, which is a horizontal compression. So if you can take a look at that blue graph is a horizontal compression of 2 of the red graph. So if you can look at a few coordinates here where the x-intercept is 0, the blue x-intercept is going to be at 1/2. So it's a horizontal compression. So I've also shown that in that last problem, we showed that horizontal compression can be algebraically manipulated to the outside of that log function to make it a vertical shift of +1. So if I graph that vertical shift of +1, I turn that graph on, that green graph lays right on top of that blue graph. So if I turn it off again, if you can imagine that red graph being shifted vertically up 1 instead of horizontally compressed, you can see that the shapes of the graph actually coincide, and it will just vertically translate +1. So again, turning it on, that graph ends up, that green graph of +1, the vertical shift of +1, is equivalent. Okay, so we can also, I think we also looked at the horizontal, a change being the base change. So if I graph the base change, okay, base 8 of x, okay, if I turn that on, that looks like, and it looks like it could be a vertical compression. So the 0 stays the same, but everything looks like it's been vertically squished towards the x-axis. So that red line gets squished towards the purple. And we can graph that 1/3 on the outside, and that 1/3 base 2 of x is indeed the exact same function. So you see that black function, which is a vertical compression of 1/3, actually is equivalent to the purple one, which is a change of base from base 2 to base 8. So change of base can be algebraically manipulated. In this case, we did the cube root on the base and the power, the base and the argument, and pulled the cube root out on the outside. And we can show that that change of base can be algebraically manipulated to the outside of the function, which makes it a vertical transformation. So there it is. That change of base actually can be shown as a vertical compression, and we can algebraically justify this as well by using some log properties. Okay, just like we could algebraically justify this +1, the vertical shift of +1. So turn these off. This vertical shift of +1 is algebraically equivalent to a horizontal compression of 1/2.